Let's recap the concepts of reflection. So we will be focusing on reflection of a point on a plane mirror. And if you remember that whenever we have a reflection on a plane mirror, the distance of the object from the mirror is always same as the distance of the image from the mirror. So we will be using this concept in this topic. Now suppose this is a topic of coordinate geometry, so we will have the xy coordinate axis and some points on the xy plane, and then one of the axis or some other line can act as a plane mirror. So we can imagine one of these lines as a plane mirror, and we will have a point which will represent the object, and we would need to find the coordinates of the reflected point, like where will we find the image, like what will be the coordinates of the image. So suppose we are looking at reflection of a point on the x-axis, so we will have to imagine the x-axis as a plane mirror, and accordingly we will have to find where is the image. So suppose we have a point, let's say A, with the coordinates 3, 2, and x-axis is acting as a plane mirror. Then if I want to find the image, I need to look at how far is the object from the mirror. So if I see that it's 2 units above the mirror, right? The x-axis is the horizontal line, point A is 2 units above the mirror. So then if I go 2 units below the mirror, this point, let's say A dash, will represent the image. So 2 units above the mirror is my object A, so 2 units below the mirror, below the x-axis, will be my image A dash, and the x coordinate remains 3, but the y coordinate will be -2. So the point A 3, 2, when reflected on the x-axis, the image is A dash with the coordinates 3, -2. Now let's look at another point. Let's say we have point B with coordinates -2, -3, and x-axis is on top of this point, and if I look at it, the x-axis is actually 3 units above this point. So then the image will be formed 3 units on the other side of the x-axis, on top of the x-axis. So if I go 3 more units on top, I get this point, let's say B dash, and the x coordinate is still -2, but the y coordinate is 3. Right. So then if I say in general, if I had any point x comma y, any point p x comma y, if I reflect that point on the x-axis, the image p dash will have coordinates x comma minus y. So the x coordinate under reflection on x-axis remains the same. X coordinate remains the same, but the y coordinates sign will change. The y coordinate, whatever was the sign, will change. If it was positive, it becomes negative. If it was negative, it will become positive. Now similarly, let's look at reflection of a point on the y-axis. So here we considered the y-axis as my mirror, and now let's say that I had point A again with coordinates 3, 2, and my y-axis, the vertical y-axis, is my mirror. Then let me check how far is my object from the mirror. So I will see that it is at a distance of 3 units on the right side of the mirror. Then my image will be formed 3 units on the left side of the mirror. So if I go 3 units on the left, I get this point over here. So this is my reflected point A dash. X coordinate here is -3, but the y coordinate is still 2. And if I see point B is -2, -3, and I am reflecting again on the y-axis. So if I see that point B, it is 2 units on the left side of the y-axis. So if I go 2 units on the right side of the y-axis, I will get the reflected point. So the reflected point or the image will be formed at B dash with x coordinate 2, but the y coordinate is same as -3. Okay, so then in general, if I see any point x comma y, any point P with the coordinates x comma y, when we reflect on the y axis, the image P dash will have coordinates minus x comma y. So the y coordinate remains the same, but the x coordinates sign will change. Now suppose we are looking at reflection of a point on the origin. The origin is the coordinate 0 comma 0. Alright, so suppose we have the point A with coordinates 3 comma 2. Now origin is just a point. We need a line, a mirror line. So the idea is that if I, let's say, connect this point A with the origin, I will get a line something like this. Now the mirror will be considered perpendicular to this line. So if I look at something perpendicular to this line, it might look something like this. So in the case of reflection on origin, I will have a mirror passing through the origin which is placed perpendicular to the line joining the object and the origin. And now the image will be formed the same distance on the other side of the mirror. So suppose we have the distance OA. If I take the same distance and trace it backwards, I will reach a point somewhere over here. So I will reach a point somewhere over here. Let's say this is point A dash and the coordinates are -3 comma -2. So the point A 3 comma 2 reflected on the origin will give the point A dash -3 comma -2. In the same way, if I look at the other point B, which is, suppose if I have point B with coordinate -2 comma -3, then if I do the same sort of reflection on the origin, I will expect a point over here which is B dash and the coordinate will be 2 comma 3. So in general, I can say that any point P with the coordinates x comma y reflected on the origin will give me a point P dash with the coordinates -x comma -y. So in case of reflection in the origin, the sign of both x and y coordinates will change. Now let us look at the equation of the x and y axis. So x axis is represented by the equation y equals to 0, and any line which is parallel to the x axis will have a equation y equals to some constant value, y equals to a, some a constant value. Now y axis, the equation for y axis is x equal to 0. So any line parallel to the y axis will have an equation x equal to some constant. Let's look at some example over here. Let's say the red colored line is a line parallel to the x axis and it is 2 units above the origin. So then I will say that the equation of this line is so it is 2 units above the x axis. So the y value, the y coordinate on any point on this line will always be 2. So I will say that this line is y equals to 2. X coordinate on this line can be anything, but the y coordinate of any point on this line is fixed. It is y equals to 2. Similarly, the blue colored line is a line parallel to the y axis and it is 3 units on the left side of the origin. So it's in the negative x direction. So I will say that the equation of this line will be x equal to -3. Now suppose in case there is a question where there is a given point and we need to reflect along one of these lines, we will consider one of these lines as the mirror. For example, let's look at point A with coordinate 3 comma minus 1, and let's say I'm reflecting point A on the line y equals to 2, the red colored line y equals to 2, then I need to find out that how far is this point from the line. So I will see that if I count the boxes, it is 1, 2, 3. It is 3 units below this line. The point A is 3 units below this line y equal to 2. So if I go 3 units above this line, 1, 2, 3, I will get this point. So if I go 3 units on top of this line, I will get this point, let's say A dash. Then the coordinates of A dash will be, the x coordinate is 3 and the y coordinate will be 5. So this is how I can find the coordinates of the reflected point on any other line. And let's say I had a point over here. Let's say this is point B and the x coordinate is minus 5, y coordinate is minus 3. And I am reflecting point B on the line x equal to minus 3, the blue line. Then I have to see how far is this point from the line. So if I see that this point is 2 units on the left of the line, so I can predict that the image will be 2 units on the right side of the line, and I'll get the point B dash where the x coordinate is minus 1 and the y coordinate is minus 3. Right, so this is how I can find the reflected point on any line x equal to a or y equal to a. Now, in some questions of reflection, the question will ask you to find the suppose after you get some reflected points, then they can ask you to join some points in sequence, join the points with straight lines, and then finally name the closed figure formed, or the geometrical figure, or the geometrical name of the figure formed. So always understand that they are asking you to name the polygon. You should not write any common names like arrow, star or anything else. You should name the polygon. So just to recap names of polygons, the smallest number of sides is 3. We need a 3-sided figure to form a closed polygon, and that will be a triangle. If we have 4 sides, it's a quadrilateral. But again, triangle and quadrilateral are in general. If you find out that there are any special properties in the triangle and quadrilateral, some sides are equal or some angles, some property which will lead you to a special type of the triangle or the quadrilateral, you must name exactly according to that. So suppose the triangle has 2 equal sides, so it will become an isosceles triangle. Or if it has 2 equal sides and a right angle, it will become a right angle isosceles triangle. Or suppose for a quadrilateral, if you see that the opposite sides are equal length, then that's a parallelogram. So like that, you need to write the special type of the triangle or the quadrilateral. Now if the sides are more than 4, if you have 5 sides, it's a pentagon, 6 sides hexagon, 7 sides heptagon or septagon, 8 sides octagon, 9 sides nonagon, and 10 sides decagon. Now for these figures, pentagon till decagon, if you find out that all sides are equal, either you can see that visually, or if you take your ruler and measure the sides, it's the same length for all the sides, then it becomes a regular polygon. So suppose if it had 5 sides and all the 5 sides are equal, you should mention it's a regular pentagon. If it's not regular, then there's no need to mention it's irregular, but if it's regular, we need to mention it's a regular polygon. Another kind of polygon can be a concave polygon. Usual shapes, the shapes that we usually draw for any polygon is a convex polygon. For example, if I'm drawing a quadrilateral, it will look something like this. So all the angles um, in the polygon will be um, up to, you know, less than 180 degree. It will be up to an obtuse angle, the interior angle. But suppose if I have a quadrilateral like this, then one of the angles is more than 180 degree. It's the reflex angle. That case, this becomes a concave polygon. So if it's a convex polygon, we don't need to mention it separately, but if it's a concave polygon, it's better to write that it's a concave quadrilateral or a concave pentagon, anything. Now the last thing that can be asked is to find the area or the perimeter of the shape. So for any given shape, you just need to, let's say for area, either use the formula for the shape, like if it's a triangle or if it's some sort of a quadrilateral, you can use the formula as you would have learnt in 9th grade. Or if you don't remember the formula, or if you don't want to use the formula, that complex figure, you can break it down into simpler triangles, rectangles and so on, then individually find the areas and add up the areas. It will give you the area of the total shape. And for perimeter, either you can measure the length of the sides with your ruler and add them, or you can use distance formula that you have again learnt in 9th grade.